As they're hopefully coming up, I will say that I think in the agenda that Jacek said, trust us, you won't want to miss these announcements. I'm not sure that necessarily applies to my segment of this. I've always believed in under-promising and over-delivering, and that seems to be kind of a big promise to live up to. But here's the announcement we're going to make. The elevator speech is that we have formed and we'd like to expand a working group to work on an array query language. So why do we need an array query language? Well, arrays and sets are different. We have a great set query language, relational query language in SQL. Arrays are a little different in a number of ways. They have dimensions, which in some sense are indexes on the data. Within the dimensions, they have order. So some dimension values are less than or greater than others, and there's a strict order amongst them. And there's also adjacency, which is another property slightly different from order, in which you know that two things are next to each other within an array, rather than separated by some distance. So there's a long history of arrays being incorporated with relational databases. In SQL 2003, this was formalized to some extent, but typically arrays have been used in stored procedures and as column types, not as fundamental data structures within the database. And one good example of this, we heard about a little bit yesterday, is RASDaMAN, which has extended the query language beyond SQL to include various array operations, multiple attributes per array cell, and these operations can be done over all arrays in a set. But fundamentally, an array is still a column type in some sense within RASDaMAN. So there are a number of systems that have been emerging over the last few years that treat arrays as first-class objects, in which the arrays can actually be named, that you can have operations that combine two or even more arrays, that you can do binary operations on the arrays or join them in various interesting ways on their dimensions or on their values. So some of these implementations that you may have heard of, they've been floating around here on posters and in talks, or SciDB, also supported by Paradigm 4, which has only arrays. That is the entire data model there. And MonadDB's cycle, which Jenny presented yesterday, which has arrays that are incorporated within existing SQL databases, and in which arrays and tables manage to interoperate pretty well. So the goals of our working group kind of took on two tracks. So the first was to come up with a common algebra to describe operations on arrays. And this can apply to both the operations with arrays as a column type and operations on first-class arrays, which would be an extension. And then also for the first-class array systems to come up with a common syntax for common uses. And the idea here is to kind of leverage the same kind of economies of scale that SQL has provided to set algebra and the relational model, come up with a way for users to reuse their queries even in different systems. So why am I here? I may have helped a little bit with SciDB in the beginning, but I'm not part of the SciDB group right now, and I am also not part of the MonadDB crowd officially. So what is the role of XLDB and SLAC in particular? I see it as bringing these groups together, building consensus where possible, being kind of a neutral broker, providing some research and ideas, and doing sort of project management to organize this and keep the whole structure moving forward. And so it's not just me. Actually, there should have been somewhere back here. Yeah, a list of contributors, including Peter Baumann of RASDaMAN, Jacek, myself, Martin Kirsten of MonadDB, Dave Meyer, Portland State, and Mike Stonebreaker, who's obviously worked on a bunch of things, including SciDB. So what have we come up with so far? One of the things we wanted to do was start small, start with a small group of contributors, not make this a committee, designed by committee, but have a working group that's actually involved in building real things and seeing how they can work together. So we came up with an algebra. This is mostly due to Dave Meyer. It has a box that defines the dimensions and bounds of the array, a validity map that tells which cells actually have valid content in them, and then a content function that maps from the dimensions into tuples of attributes. So again, you can have multiple attributes per array cell. The operators, rename, shift, rebox, a whole bunch of different operators that can be used internally to certain operations or can actually be exposed to the end user to accomplish various tasks that are necessary. And these are fairly general and can be expanded to do most kinds of operations that people want to do on an array. So we came up with that draft algebra. There's a document for that will be released, I think, either today or tomorrow. And we've also been working on a draft syntax, again, for the first class array implementations. And it would look something like this, where we're focusing initially on how to create arrays and how to query them, not so much on how to do inserts or updates. And we purposely tried to make it as close to SQL as possible. So we have create arrays, select from an array, and create from select, which is pairing the two together. So create array would really look something like this, in which we create a matrix. We have certain dimensions that are specified by dimension clauses with a range for minimum and maximum values as the bounds of that dimension, and then the attributes as a tuple. So queries might look something like this. This is a relatively complex one that actually does a matrix multiply of two different matrices. I'll break it apart a little bit. So first we start with a select clause that has dimension expressions in it. So these actually define the dimensions of the output array. It's a lot easier to define what the output will be and then map that to the input rather than try to take the input and map it to the output. And then we have subarray expressions that allow you to use the output indices to index into the inputs. So this is something that is necessary to do that kind of mapping. So relatively simple syntax for doing that. Our goal was to have something that would look like SQL, but would still be familiar to the scientist user that would use the same kinds of notations that they're used to. We have also defined how this would work with a where clause and group by, both of which can include the dimensions as well as the attributes, although grouping by attributes is still a little complex. We're working on that. And so here are some overall examples. The first one is just essentially copying an entire array. So there's some shorthand in order to use the dimensions from the input array. There would be, you can select out a subset of an array or a sort of a chunk of the array, a piece of it. You can transpose an entire array just by changing the order of the indices. You can filter out the elements of the array and leave some of the resulting cells as invalid by putting a where clause on it, on either dimensions or on attributes. You could actually slice an array and reduce its dimensionality. In this case would be producing a one-dimensional array from a two-dimensional array by selecting it out, selecting on a particular column. And then we could combine two arrays, not necessarily overlapping exactly, but potentially offset. And we could aggregate over parts of an array and even do, in this case, this would be an attribute dimension join where we're using an attribute from the first array to index into the dimensions of a second array. And do a lookup that way. So all of these operations are ones that are already supported in the implementations that we're looking at, and we're just coming up with some common syntax in order to be able to express them. So I think I'm winding up more or less on time here. What we're asking for is to read the draft documents. These are works in progress. They're not published. They're not finished by any means. There's still a lot of to-dos in them. We need to draw a lot more diagrams for one thing. But we feel that they're at a stage where they're potentially useful and where they set a base that we can go out to the community and ask for contributions. So we'd like anybody who's interested in the algebra or the syntax to read these and send comments to our mailing list and hopefully join our working group. Thank you very much. Any questions? Yes. You want to do mics or?
Yeah, let's do mics.
Just a quick comment about the SQL syntax. I work a lot with the MDX language, and I think it was the biggest design mistake they made with the MDX language was making it a SQL-like syntax, because the users see, oh, select from where. I don't need to learn this language. I can just use what I know from SQL. So they don't bother to read the documentation. They start off with things. They go about things the wrong way. So if it's sufficiently like SQL, fine. But if it's different from SQL, make it look different, so that your users realize they actually have to open a book and learn the language.
Okay, that's some interesting feedback. I think we're trying to make it, well, I think there are two aspects to this. One is to try to leverage some of the familiarity for things that are similar, but another one is that, in particular for Cycle, which integrates arrays and sets together, it's nice to be able to express that all in the same kind of manner. So we are trying to accommodate that in that way. Yeah.
So I might have missed this, but a lot of standardization efforts have also a reference implementation. Do you have one?
Not at this time. We've been. I even hesitate to call this a standard effort, but it's an attempt to bring these groups together and come to some common, to achieve common goals with a common syntax and common algebra. So again, as I said, all the operations that are being performed here can be done in the existing systems, but modifying those systems to use this syntax has not yet been done, but it will be. And
Peter Baumann speaking. Let me come back to the first comment. What you raise is actually something that also has been discussed within our group. And as KT has mentioned, there are, so to say, two different strands. The one is see it from an SQL perspective, integrated tightly with SQL. And the other one is come from the perspective of, let us say, languages that use arrays and try to transpose this language into SQL so that it is distinct. This is something that is under discussion, and which please put it on the mailing list so that we can continue that maybe.
Any other questions or comments?
okay, I'll turn it over to Yasser.